there's a little bit of space here. That's not quite, everything that's under there, but it's pretty close to what the actual area under that curve would be. So the integral, or the definite integral, from 1 to 7 of f of x dx is approximated by these trapezoids. We have 1/2 times this times the width, or the height of it is 1. And what do we start with? F of 1 plus 2f of 2 plus, yeah. It's going to be 2 all the way until what?
6.
Yeah, f of 6 will be the last one, and then f of 7 will be all by itself. Is that what you're saying?
Yeah.
Okay. Oops.
Are we plugging all this in?
No, I'm just going to give the answer. I mean, I figured we can run the calculator. So that is 39.667. Okay, so this next part, over here, notice it says in our next lesson we're going to find the exact area. So we're not doing that yet. We're going to come back to this and find what the exact area is. So,
Miss Kane.
yes, ma'am.
Let's see if we checked out.
Okay, thank you. Actually, I'm going to fill in all the rest of this when we come back, because that makes more sense. All right, so skipping that page. Oh, what just happened there? We are now on to page 44. So we're going to do the same thing that we did yesterday, but now with tables. So these are a little bit easier, I think. By given the table of values below, approximate each definite integral by finding the indicated Riemann sum. So we're approximating 0 to 25 of f of x dx. We're using a midpoint sum and 3 subintervals. So that means we're going to split this up into 3 groups. So like, here's one group. There's another group. And we know they overlap because when you draw rectangles, they're going to share a side. And as long as they're split up evenly, we're good. Now, I don't mean they have to be the same size. I just mean we have 3 boxes in between each one. All right, so to find the area is length times width. The length part, or width part, whichever, one of them is going to come from up here. So how far it is from 0 to 7? Well, we know that's 7. Let me leave that in black, actually. I know which one goes with which. And then it's a midpoint sum. So that means when we draw in the rectangle, say you have f of x that looks like this. When we draw in our rectangle and it's going from 0, 4 to 7, at 4, so is the middle of the right, that's where it's touching the curve. So that's the midpoint of that rectangle, the middle of the rectangle, although it's not technically the middle. So that means the height is going to be going with this middle number. So our base, or length, or whatever, was 4, and our width, or height, whichever way you want to look at it, is 6. Now, if you didn't watch yesterday's video, there may be a little bit of a learning curve here. So for the next one, how wide is it? 8. It's going from 7 to 15, so that's 8. And then what is my height? -10. Now, how can you have a -10 height on a graph? Yeah, it's just means direction. It's just going in the other direction. It's down below the x-axis. Does that make sense? Yes, it is. It's probably, doing something weird like that. So the next one then is going to be the width. 10, and the height? 40, whatever.
Yeah.
8. Good. So now we just work that out. So that's 42 plus -80 plus 80.
So it's just 42.
So it's just 42.
And that's about the area.
That is about the area under the curve for f of x. It's an approximation. Okay, so the next one is the same set of numbers. But this time we're using a left-hand sum. And we're using 4 subintervals. So I don't need groups of 3. I just need 4. And a left-hand sum. So we're going to go 1, and they got to overlap because the rectangles have to touch. 2, 3, 4. And we're not going to worry about these last ones because it's a left-hand sum. Now, if it said 5 subintervals, we would do another one. And actually, these would not be given to you. I just copied and pasted it, but it would be exact for you if it was on the test or whatever. So you wouldn't even have to worry about those. All right, so this time, and it said from 0 to 15. So that's another reason we need to stop at 15. I didn't see that. So 0 to 15, f of x dx.
You meant to do it.
What?
You meant to stop at 15.
I did. And so, what's the width? 4. Now, the height this time, since it's left hand, would be which one?
15.
15, that's right. Okay, the next one?
3.
Yep, from 4 to 7 is 3. And 6, always the left one. Correct. The next one?
5.
5 and -5. And the last one? 3 and -10. Very good.
Wow.
And that is 23. According to my notes, hopefully it's right. Feel free to double check it. Okay, let me look at the problem before I go on. Next one says I'm going from 4 to 20. So I don't have to worry about this one. And I don't have to worry about this last one. So the integral from 4 to 20 using a right-hand Riemann sum, and it has 4 subintervals. So that means 4 rectangles. So 1, 2, 3, 4. All right. So that is 4 to 7. 3 times -5 this time because it's a right-hand Riemann sum. So then 5, -10, 3, yep, 5, 8. Very good. Oh, I don't know why I put 60. That should have been 6. And that one is -31. So that means most of its area is below the x-axis. Okay, on the next one, we're using a trapezoidal sum and 3 subintervals. So it is from 0 to 25, so the whole thing. So 1, 2, 3. So remember, it's 1/2 times the width. I'm going to have to do each one separately because the width of each one is different. So for the first one, it's 7. So that's 7 over 2, or 1/2 times 7, times 15 plus -5. There's the 2 sides of the trapezoid. That make sense? Okay, from 7 to 15, that's 8. So 8 over 2 is 4. And it's going to be -5 plus -2. 15 to 25, that's 10 over 2, so that's 5. And then -2 plus 20. If you work all that out, you get 97. Oh, sweet. And now you're good to do day, I guess that's a 4. Day 54 homework.